Hey everyone, it's Dr. J and welcome to this presentation of the weather and flying. This presentation is lengthy, therefore I suggest that you consider watching it in 6 to 8 minute chunks and taking a short break between each chunk. Further, I have divided the presentation into 2 parts. I will cover much about weather in this presentation. Quite honestly, unless you are a weather fanatic, you may find this information boring. Nevertheless, we cannot ignore that weather affects flying. Some of this information will apply to drone flying. However, there is much that will not, and you may wonder, why am I covering this information? The answer is that some of you may intend to take the FAA Part 107 exam, and you need to know this information for the exam, even if you feel it has little to do with drone flying. Even if you do not have any intention of taking the FAA Part 107 exam, it is good to know what public safety drone pilots must understand about the weather in order to fly the drone. The atmosphere is about 78% nitrogen and 21% oxygen, with traces of other things like water and carbon dioxide. It is an odd mix compared to the atmospheres of other planets. Jupiter and Saturn, for example, are dominated by hydrogen and helium. The thick atmosphere of Venus is about 96% carbon dioxide and only 3% nitrogen, which is about the same ratio as the thin atmosphere of Mars. Currently, Earth is the only planet of which we know with an atmosphere that has been found to sustain human, plant, and animal life as we know it. Atmospheric circulation, or what we commonly know as wind, is the movement of air at all levels of the atmosphere over all parts of the planet. The driving force behind atmospheric circulation is solar energy, which heats the atmosphere with different intensities at the equator, the middle latitudes, and the poles. Differential heating causes air to rise in the atmosphere at some locations on the planet and then to sink back to the Earth's surface at other locations. If the Earth did not rotate but remained still, rising air at the equator and sinking air at the poles would cause winds to blow north to south or south to north depending upon which hemisphere you are in. However, the Earth's rotation on its axis and the unequal distribution of land and water masses on the planet contribute to the east-west or vice versa movements of air. Similarly, the heating, cooling, and movement of air contributes to changes in atmospheric pressure. Since aircraft depend upon their ability to create lift in the air, wind flows and air pressure are important to pilots in controlling their aircraft. Even air heating creates small areas of local circulation known as convective currents. Turbulence is one of the most unpredictable of all the weather phenomena that are of significance to pilots. Turbulence is an irregular motion of the air resulting in convective currents. Many of you who have flown have experienced turbulence. It may be as insignificant as a few annoying bumps, are severe enough to momentarily throw an airplane out of control or to cause structural damage. Turbulence is associated with fronts, wind shear, or thunderstorms. Drafts and downdrafts are upward moving and downward moving air currents, respectively, that are due to several causes. Local daytime heating of the ground causes surface air to become much warmer than the air above, and because warmer air is less dense, it rises and is replaced by descending cooler air. The vertical ascending current, called a thermal, may reach an altitude of 2 miles or more. The greater the radius of the thermal, the higher it is likely to ascend. Strong updrafts and downdrafts occur in thunderstorms as well. Updrafts characterize a storm's early development, during which warm air rises to the level where condensation begins and precipitation starts to develop. In a mature storm, updrafts are present alongside downdrafts caused by cooling and by falling precipitation. These downdrafts originating at high levels contain cold, dense air that spreads out at the ground as a cold air wedge. The sharp changes in wind direction associated with downdrafts near the ground are a threat to aircraft during landing and takeoff. Intense downdrafts are called downburst or microburst. Updrafts and downdrafts also occur as part of the turbulence that is created when air passes over topographic barriers such as mountains. Air over mountains or similar obstacles can be unsteady and unpredictable. One of the reasons that there are so many small aircraft crashes in mountainous areas is not because the pilot simply flew into the mountain, but rather because his or her aircraft was caught in a downdraft that pulled the aircraft into the mountain. The air around us has weight and presses against everything it touches. That pressure is called atmospheric pressure or air pressure. It is the force exerted on a surface by the air above it as gravity pulls it to Earth. Air or atmospheric pressure is commonly measured with a barometer. In a barometer, a column of mercury in a glass tube rises or falls as the weight of the atmosphere changes. Meteorologists describe the atmospheric pressure by how high the mercury rises. Air pressure is affected by its altitude or temperature, which also affects air density. Air pressure affects the ability of aircraft to take off, climb, or land. My cousin's husband was a helicopter pilot in the U.S. Army and served in the Vietnam War. Vietnam is located close to the equator where the air tends to be very warm. I remember hearing stories from my cousin's husband about how difficult it was for helicopters to take off during the summer in Vietnam when the helicopters were fully loaded. He said that helicopters would have to get a running start similar to an airplane taking off before the helicopter's rotor blades could generate enough lift for the helicopter to get airborne. Further, even after they were in the air, it took a long time to climb to their desired flying altitude. Airport runways tend to be longer in areas that are closer to the equator due to aircraft needing longer takeoff runs to get airborne. Technically, air is less dense when it is warm and/or located at higher altitudes. However, the term that many pilots used is to describe the air as being thin. Because there is less air under these conditions, the aircraft and its engines must work harder to move a sufficient volume of air across the wings or rotors to create lift when the air is thin. This slide represents information that you will need to know if you take the Part 107 exam. Therefore, the purpose of this slide is to introduce you to terminology related to air pressure. I have shared with you that air is less dense at higher altitudes. This gives rise to the term lower density altitude. Do not let this term confuse you. Some people focus more on the words lower and altitude when they should be focusing on the words lower density. Remember that lower density altitude refers to the thinner air at a higher altitude. Conversely, the air is denser at lower altitudes, and we use the term higher density altitude to describe this condition. Please be aware of what these terms mean. You will see them on a Part 107 study guide and exam if you plan to be an FAA certified remote pilot. The effect of air pressure is that it can be powerful enough to create fronts. A weather front is a term used to describe the front end or advancing edge of an air mass that will soon replace the air mass that's over a specific region. When two different air masses collide, the warmer air rises above the colder, denser air. In the northern hemisphere, most fronts travel from west to east, carrying clouds and rain. As a front passes through an area, changes in wind speed and direction, atmospheric pressure, and moisture result. Wind shear is a difference in wind speed or direction over a relatively short distance. Atmospheric wind shear is normally described as either vertical or horizontal wind shear. Vertical wind shear is a change in wind speed or direction with change in altitude. Horizontal wind shear is a change in wind speed with change in lateral position for a given altitude. Wind shear is commonly observed near microburst and downbursts caused by thunderstorms, fronts, areas of locally higher low-level winds, near mountains, radiation inversions that occur due to clear skies and calm winds, buildings, wind turbines, and sailboats. Wind shear has significant effects on the control of an aircraft, and it has been a sole or contributing cause of many aircraft crashes. Low-level wind shear is more dangerous to aircraft than high-level wind shear due to its proximity to the ground. Wind and directional changes can occur. However, when a direction change occurs that forces an aircraft towards the ground, the pilot has less room to recover from the wind shear than at higher altitudes. In many cases, the result is a crash. Active precipitation occurs over relatively small areas. They are the result of the sun superheating the earth, causing air and water vapor to rise and form clouds. When the air cools enough, rain will fall. In some cases, there can be a large amount of rain falling. When the rain mixes with a strong downdraft of air, it is referred to as a microburst. Some microbursts can pose a threat to life and property, but all microbursts pose a significant threat to aviation. Although microbursts are not as widely recognized as tornadoes, they can produce comparable and in some cases worse damage than some tornadoes produce. In fact, wind speeds as high as 150 miles per hour are possible in extreme microburst cases. Atmosphere stability depends upon its ability to resist the movement of air up or down through the atmosphere. When the air is warmer at higher altitudes and cooler at lower altitudes, the atmosphere is stable. This is due to the tendency of warmer air to rise and cooler air to sink. Since the warm air has already risen and the cooler air sunk, there is little to no air movement, leaving the atmosphere stable. Conversely, when the air is warmer at lower altitudes and cooler at higher altitudes, the warmer air will rise and disrupt the cooler air. This creates an unstable atmosphere. When warm air rises and cool air sinks, turbulence can occur. Further, warm air is often moist. As it rises into the cooler air, the moisture condenses and forms rain. Therefore, there are often rainstorms and thunderstorms associated with unstable air. Dispersion layers are shallow layers of cool, stable air close to the ground. However, as you increase your altitude, you will find that the air is warmer rather than cooler. Find warmer air at an altitude higher than the cooler air, an inversion occurs. The warmer air can trap the cooler air below it. Warmer air acts as a lid and keeps the cooler air and its contents below. When the cooler air has high moisture content, fog can occur. When there is a large amount of moisture and pollutants in the cooler air, smog can occur. 4 different types of inversions. The first type is nighttime or radiation inversion. This is the most common inversion type. During the evening hours, the surface-based nighttime or radiation inversion is weak and shallow, usually no more than a few hundred feet deep. As cooling continues overnight, the inversion strengthens and eventually reaches its maximum depth around sunrise when surface temperatures are at their lowest. Frontal inversion occurs when a cold air mass undercuts a warm air mass and lifts it aloft. The front between the two air masses then has warm air above and cold air below. This kind of inversion has considerable slope, whereas other inversions are nearly horizontal. In addition, humidity may be high and clouds may be present immediately above it. This type of inversion is unstable and destroyed as the weather changes. Marine layer is an air mass which develops over the surface of a large body of water. The inversion is usually initiated by the cooling effect of the water on the surface layer of an otherwise warm air mass. As it cools, the surface air becomes denser than the warmer air above it and thus becomes trapped below it. Fog will form within a marine layer when the humidity is high enough and cooling sufficient to produce condensation. Subsidence inversion develops when a widespread layer of air descends. The layer is compressed and heated by the resulting increase in atmospheric pressure, and, as a result, the lapse rate of temperature is reduced. If the air mass sinks low enough, the air at higher altitudes becomes warmer than at lower altitudes, producing a temperature inversion. Subsidence inversions are common over the northern continents in winter and over the subtropical oceans. These regions generally have subsiding air because they are located under large, high-pressure centers. Humidity is the amount of water vapor in the atmosphere at a given time. Humidity affects the way an aircraft flies because of the change in pressure that accompanies changes in humidity. As the humidity goes up, the air pressure for a given volume of air goes down. This means that wings have fewer air molecules to affect as they are pushed through the air mass. Fewer molecules equal less lift. Point is the temperature to which air must be cooled to become saturated with water vapor. When cooled further, the airborne water vapor will condense to form dew. When air cools to its dew point through contact with a surface that is colder than the air, water will condense on the surface. When the temperature is below the freezing point of water, the dew point is called the frost point, as frost is formed rather than dew. The measurement of the dew point is related to humidity. A higher dew point means that there is more moisture in the air. This concludes the presentation of the first part on weather and flying. Please do not forget to watch the second part. Thanks for watching.